Hey, folks. I wanted to just do a brief little discussion about what I want you to do for the of the 3D modeling, stadium 3D modeling of Spartan Stadium. So, we had some more oblique angles thrown into the mix here. And our goal is to really, densify this 3D model. We're going to roll with Pix4D again. In terms of the cloud, we're going to bypass Mapper because I know that was hard. Not your fault. In cloud, I want you guys to go ahead and create another account. So you got to do another trial, unfortunately. And you may want to try to time this right because these trials are only 14 days. So time it in a way that you're sure that what you embed on Canvas will be there long enough for the due date. So anyways, make sure you do that. All right. Make sure you could also try to email the company through the support and just say, hey, can I get an extension on my trial? 99% of the time they'll do that for you so you don't have to use a different email. But yeah, I mean, that's just kind of what we have to do to work through this. Okay, I want you guys to, when you go to Canvas, I want you to, sorry, I'm jumping around here. I want you to download from this link here, Drive link all students. You know, the overhead aerials we did were essentially the same missions for both groups. So it kind of doesn't make sense for us to, have two different file sets for that's the exact same thing. And with group one, you guys flew along the facade, kind of scanned along the facade. And I've been doing a lot of testing with this data before I release this video to you guys. And I think it's the best thing to do is just release the best version of what we have to work with and give that to you. Okay, so you're going to be looking at a combination of, actually it's a combination of group one data, as well as some overhead at 200 feet from field day 4. And the reason being is when we go over those bleachers, there is a lot of holes or gaps that exist over the top of the bleachers because they're so tall and we didn't get quite high enough at only 150. So if we bump up to 200, then we can kind of complete that whole surface there. So it's a little bit of data magic, not really, but just things that I've worked on before, like I said, giving this out to you guys. Yeah, but it's all there. And when you click on this, it's going to take you to Drive. Now, here's the two different, I've got two different data sets for you. Group 2, you guys did a point of interest around the scoreboard. So I'd like everybody to actually download both of these data sets. Okay, both of these data sets, the stadium, that's the complete stadium, and then the scoreboard. The scoreboard should be more of a denser 3D model of just the scoreboard itself, as we did that point of interest. I want everybody to do this, okay? Not just group 2, everybody, all right? So you get this all downloaded, then go ahead and copy that over to, extract all these image files. Keep them separate though, right? Make one folder for the stadium, make one folder for the scoreboard, okay? Keep them separate because when you load to Pix4D Cloud, you're going to be processing two different projects. Okay, so keep these items separated as you paste them in on your hard drive. Let's see what's next. Looking at my list here: download Stadium, create new account. Cool. Let's go to the cloud now, and I'll show you what I want you to do. So go ahead and create a new folder, and I mean, you could call this folder field day 5 if you want. Okay, so go ahead and open that up, and then we'll just work through the stadium first. Okay, so you're going to go to over here, new site. Okay, new site. And then why don't you go ahead and put stadium. Okay. Create site. And then go ahead and do new again, new site. This time you could do scoreboard. Okay, create site. Oh, I guess I have done this in a previous iteration. So I'm going to just say scoreboard one like that. Okay. But it doesn't really matter. I don't care what you name these, honestly, because you're going to embed them, and it, that part doesn't even, that part is arbitrary anyways. When you go to like Stadium, for example, again, you've separated these on your hard drive. So when you go to Stadium, you're going to, yeah, where it says upload images, next. And then I think there's a glitch also here. Like if you try and drag and drop, I found that myself this morning. So if you just go to select images, that seems to work reliably. Let's see here. So I'm going to go to the images that are, here we go, group 1 plus 200 feet images. And it should be 572 images. Okay. So you can select all of those, say open. You already know how to do this part, right? So you'll let that do its magic. It'll upload. It'll probably take a while. It's a lot of data. Once it does upload, okay, there's a little button at the bottom that says start processing, a little kind of slider, start processing when finished upload. That should stay automatically on. You want that to happen so you don't have to think about it. Again, I found there to be somewhat of a glitch here intermittently. I know these people have a lot of problems, but their software does some killer stuff. When you finish the upload, you might want to check back. Also look at your email. It should be sending you emails about progress related to is the data, what's happening with this project in the cloud. But go back to the project and all your pictures might be there, and it may say waiting for you to process. So there's a big blue button at the top right of the screen. You might need to click on that to say start processing. If it's all processing like something that looks like, let me show you an example what processing looks like. If it looks something like this, okay, your data says processing, we'll send you an email and your data is ready, you're in good shape. All right, so that's a good thing. So yeah, once you get to this stage, you wait it out and it will eventually give you some results. This whole cloud processing thing should be, shouldn't matter what kind of computer you have once you get your data uploaded, right? The uploading piece is actually the hardest part. Once it's in the cloud, everybody's on the same level because it's using then this Pixelworld servers, cloud servers, and machines to do all the processing. So there is no specifics in terms of hardware limitations at that point. It's just a matter of getting it all out there. Okay. Yeah, so let me check one thing here before I try to move on, because I might need to pause this video and come back. I have another example here that I want to use. Oh, great. I think it is ready. Let's see, DSM. If I go to 2D, excellent. Okay. And if I do sorry, folks, I'm talking out loud. I was uploading this while the video was while I started taping this video. So if I do a volume, can I do a volume? It looks like I can. Cool. Okay, I'm gonna close that. Right on. So, oh, one thing I wanted to make sure I mentioned to you guys. Backing up here for a second. You are going to be, you're going to be here. Like I said, you've got all the stadium photos in this little folder. Then your scoreboard, okay, load only the scoreboard photos into the scoreboard option. when you get to the screen where it asks you what type of processing do you want to do, you know what, here, I'll just give you an example of what I want to see from you guys. I should have done this earlier, but let me select these images, scoreboard. So I have them kind of organized this way, but you will see them, you'll see them come out much differently. This is like 43 or 44 images, something like this. Okay, so you've got all your images here. You're going to say next. Okay, I do want you guys to change right here where it says Alpha coordinate system. I want you guys to type in this number here, 2227, 2227. Okay, and then select this NAD 83 zone 3. Those that are familiar with geospatial should know somewhat what I'm talking about here. This is a coordinate system transformation. We're going from UTM, Mercator projection, to a state plane. That's not really important per se, but why I wanted to do this was because this is the easiest transformation to go from meters to feet. Okay, this way all of your measurements, when you go through that I'm going to tell you guys about here in a second, all of the measurements you make in these projects will turn in, will register imperial, feet and yards types of results, as opposed to metrics. So yeah, make sure you type that in there. That'll stick, and then you can leave the rest of this stuff as is, right? With the 3D maps, we'll leave it on quality, and then we'll say next. And you can go ahead and say skip and process. Then it's going to go ahead and do its thing. Okay. So I'm going to go ahead and previous this one. I don't need to actually upload more images because I've already done this a billion times today. But yeah, make sure you do that for both projects. Everything I just said for both the stadium and the scoreboard. All right. Okay. Backing up again to my example for you guys. Okay, now we're at the point where we've got all of our data processed, okay? And you should see something like this. Okay, here's our 3D model of the stadium in its complete form. Now, what's so different about this compared to what we did 2 weeks ago? I mean, I think if you pull up these examples, well, you know what, here, I'll just do it myself here just to show you if we have something to kind of point out. Again. Okay, that's not exactly what I was trying to do. Cloud.pix4d.com, that works better. So let's take a look at like group 2, for example. This was at a lower altitude. And if I look at November 3rd, the date November 3rd, the ortho is beautiful, right? The ortho is great. It's really crisp and clear. But notice that right around, there are plenty of artifacts that we could point out, but especially over here, when we get to the top of the stadium, right? The top of the bleachers themselves, look at all this kind of weirdness going on here, right? The 200 feet people didn't, group 1 probably didn't see this as prominent, but it's still not quite as refined as we would want it to be. And the reason being here is that we ended up losing overlap and information because we were flying at the same plane as the elevation of the objects were going up, right? If we look at the 3D, it's even more evident what happened here. So this would open up. I could show you. Oh, I have to turn the layer on. Over here. There we go. Okay. So, at first glance, doesn't really look like anything's, off. But yeah, take a look over here, right? Take a look at these grandstands. And it's almost like the whole top half is missing. You know what I mean? And there's a whole bunch of stuff behind it that is also not there anymore, right? So yeah, not having those oblique angles, also the scoreboard too, look at that. There's big chunks taken out of it, It's not necessarily the software's fault. It's again, a byproduct of not having the right, not having, I shouldn't say the right, because this is what we wanted to do in the first place, but not having the angles necessary to capture this level of detail, right? For the ortho, it's fine because the ortho is all straight down perspective anyways. But in this case, we have a deficiency here, all this stuff. Now, let me show you the difference between this version and field day 5. Okay, let's do that. And I'll do something like this. And over here, bring that to the side. Okay, so take a look. If I'll zoom out for a second, kind of give you the same perspective, side-by-side view here. I mean, for one thing, this is much brighter, which is telling us that we have a lot more detail anyways, because we captured that dual pattern. But the focus that I was wanting to really emphasize here was the bleachers themselves. Now, clearly this is not perfect over here. There are some major holes happening. I know that this bleacher in reality is not missing all of this information. If anybody throws out an idea in the discussion board why they think that may be the case, I would love to hear your thoughts on that. I have my theory, but I'd like to know what you guys think. But yeah, anyways, that part is not, that's a different discussion per se. Look at the bleacher itself, right? Let's zoom in again. See the difference between these two things. I mean, not only is the bleacher more complete here, but you have all these trees and the backside as well, much more complete, right? Again, it's not perfect, but this is a lot better than this version, okay? So yeah, based on some of the theory that I've been discussing with you guys in the lecture, I know that we didn't get a lot of face time to really kind of hash some of this stuff out, but throw your comments out there, because there's definitely some reasoning behind like, why is this all still missing, right? And why is this all not there? It's in the theory, I promise. It's in the lectures that I put out there, the reasoning behind this stuff. Okay, so anyways, you should end up with something like this. Okay, so I'm going to close this version now because we don't need to see that anymore. Okay, let's open that back up in a full screen. Uh-oh, there we go. Okay, what I want to see you guys do, well, number one, embed your map. Okay, embed your 3D models. And to turn back and forth between 2D and 3D, we just tap these little buttons down here, right? We're really only looking at, really only reviewing this data set in 3D this time around anyways. So when you do your embed, let's just make sure we understand that part. When we do the embed, you're going to click the bottom link, because the bottom link is your 3D model. The top link is your ortho. Why it's like that, I can explain it to you, but for whatever reason, that's how they developed it. So you're going to want to copy this link and embed that code into the discussion, okay? Now, you're going to have an embed of the stadium, an embed of the scoreboard, okay? And then you're going to, let's see, do some other things here too. I want you guys, you did the measurements before, the linear type of measurements. Now I'd like us to do a little bit more 3D stuff. So we can do something called the volume calculation, which is an observation of how much material is present or not present around a subject. So great example of that would be like these big stockpiles here, piles of dirt, right? And other kinds of construction materials. Having an active construction site in the data set is actually perfect. Fun fact also, I noticed that in the base map actually, let me see, I think in this one, sorry, I'm jumping around, but let me just see something here. If I look at the satellite version of this, doesn't that look different here? Doesn't that look different than what you guys are used to out there this semester and over here as well, right? So this is some active development going on. You may not have realized it, but you are observing a perfect use case of drone mapping and modeling in real time, right? And it kind of happened by accident, but the construction site and all of the different development that's occurring will be very beneficial, or at least could be, right? I'm saying this kind of hypothetically, but could be very beneficial for, this development as it continues on. A timeline of events, right? Change detection. We've talked about this stuff before. But yeah, this is completely gone currently, and it's that big concrete platform with the scoreboard that, heck, I didn't even know that thing was pretty much brand new, right? Okay, anyways, let's go back to 3D model. And yeah, I was talking about doing some different types of measuring. I'd like to see you guys do a few volume calculations. And so the piles are good examples, but frankly, anything is an example when I say that. Let me show you the piles first. Like I'll just do this big dirt pile. Now, I don't want everybody to do the exact same thing that I'm doing in this tutorial because that would be very boring, okay? I'd like to see some variety out there. If you click on this little button here, volume, and create a polygon around the pile. All I'm doing is left clicking my mouse around the base of the pile itself, right? Like this, and then right clicking to finish. Okay. So it gives me a surface area measurement here in square feet, which is okay. But I want to see the, whoops, I needed to drop that menu out on the right side there. I want to see the amount of material that is there. So after I digitize that polygon around the pile, I can click this button here, calculate volume. Okay, and it gives me some results. It gives me some cut volume and some fill volume, right? Now, basically, it's telling us that if we had a level plane along the surface of the, surface of the earth on the ground, and then we measured everything above that, it would be like we cut through whatever our subject is, and we are reporting on that result. So the cut volume is everything above the plane, right? The fill volume would be everything below the plane. So there's really nothing below this except some erroneous data. So therefore, the majority of the information here is telling us that we have a pile in this example of 140 cubic yards of dirt, right? Doesn't sound that interesting, but I promise you, for people that are involved in earthworks, like these guys, or people that are involved in kind of giving you guys some proposal ideas here, people that are involved in mining and other types of, industries where the amount of dirt or the amount of material that gets moved back and forth really matters. This is important stuff, right? Because this can be used for managing inventory. And I mean, it's hard to look at a pile of dirt and say, hey, that's how much stuff is there, right? And it sounds maybe trivial, but at the same time, for people in this industry, the amount of dirt you have to move away means the amount of trucks you have to hire, the amount of drivers you have to have, the amount of hours that stuff gets put to some other kind of place. I mean, it's all time and money, right? So this could be an extremely important asset value proposition for somebody that's involved with this type of asset. So to you, I would like to see at least two of these, okay? Two of these. Now, like I was saying, there's the fill, it does both cut and fill on the same plane, no matter what you do. If we did something like, let's see. Okay, I have an idea. I don't know how well this is going to work because I'm really doing this on the fly with you guys. But if we did something like this, where we did a polygon around kind of the bowl of the stadium, let's see if I can do this right, like this. Okay, because we know down where the actual field is much lower, right? Now I'm doing this very fast, and I know it's not going to be great, but you should get an idea of what I'm talking about here in a second. So I'm trying to keep my plane the same, and it's not great. But anyways, here's the idea, right? I just created imagine a plane along kind of the top above the, the field itself. And when I say calculate volume this time, there's a lot more for it to think about, okay, for one thing. But there you go, there's the results. Okay, we have, actually, this is quite interesting that there is so much cut. I am not quite sure why that's the case, to be honest with you. Well, oh, never mind. I was looking at my decimal places wrong. Okay, 69 cubic yards versus 53,000 cubic yards. Ha, right? Now it's actually making a lot more sense. So the fill in this example, right, the negative number here is telling us that there's 53,000 cubic yards of theoretical stuff below. I know it's hard to see. Maybe I could change the color to make this a little bit brighter. I don't know. Teal, maybe? No, that doesn't seem to matter. Oh, there we go. Okay. How about that? Okay, so everything that's, yeah, it's still not a great visualization. You can kind of see the line here, I guess. But again, imagine that I have this kind of around the bowl of the stadium there, and I'm seeing everything below that. So think if you were trying to fill up a pond, right? And you needed to know how much water it took, or fill up a pool, how much water is it going to take, right? Here's an example, right? Maybe it's a matter of cutting, removing dirt away from something, and you're trying to figure this out. So, I could go on and on about this stuff, but I want to see you guys do two different versions of a volume. They don't have to be one that's a big cut, one that's a big fill, but at least something. And you could even say, hey, how much volume is in this truck right here? It'll work. I'll promise you that. Okay, it'll work. Okay, let's see. I'm going to click back on my arrow to go back to the default view. And let's try something else. I'm going to do a line here. And I'm going to do something like this from the back side of the stadium. Kind of get back to my nadir view. And I'm just going to create a line like this along. Oh, now there's my pond. Huh? That looks cool. So I'm going to create one line from the back side across kind of horizontally like this. And I'm going to finish the line. Okay, so you have an idea of what I just created. Just two endpoints, one on one side, one on the other. Okay, I'm going to use this button down here called Generate Elevation Profile. Okay, so it's going to think about it. All right, and check out the graphic. It's pretty cool, actually, what it looks like they're doing. They're taking a 3D model, slicing it in half in this graphic, and you're going to now see. You're going to visualize the end result from a, side view, like it is a profile view. They call this a profile view, profile perspective. So sometimes this takes a while. There we go. Okay. And now move my mouse around. Check out this little ball that's on the line as I move the mouse around. Right? So it's kind of giving me in real time where I'm at. Here's the top of the stadium, right? Here's the top of the stadium. We've got a lot of strange things happening here. If I zoom in on this a little bit, I think I can move this up. Yeah, there we go. So I can make the profile kind of a bigger size. But I've got some strange things happening here. I mean, you can make out the shape of the bleachers like this, right? Especially down here and then down here. A lot of this stuff is just noise. It's noise, right? And So, you know, again, this is not the perfect data set. If we had a full semester, we could work with post-processing this data, like post-editing it to get it to be much cleaner in design, something that we would actually send to an engineer as opposed to, you know, just this kind of first version, rough draft version. But, you know, I'm trying to just emphasize what the tools can do, right? Clearly, we went over something that has a lot of noise. However, we still have the results to share with you guys, right? And it tells us that, let's see, 360. Oh, no. Okay. So this is, yeah. Anyways, look, this is all cool stuff. And again, I could continue to talk about this forever and ever. I know this video is already going much longer than I intended it to be. But what I'd like to see is that you guys copy and paste like a screenshot of your profile, right? Something like that, right? Put that on Canvas as well. Okay. You know, these things can be either of the scoreboard or the stadium. And I think that's all that I have for you guys. That's all that I have. So again, it's important that you take some screenshots of your measurements so that we could, you know, see, because when you embed the 3D models, I'll just do it here for the sake of the argument. If I say embed, I'm pretty sure these measurements don't show up in the embedded copy, right? If I close this and I go over to Canvas, let's see here. Okay, like that. Okay, so if I try to embed this, the model should come in. There it is. Very cool. Post. Okay. Yeah, so the model's there, right? So I want to see something like this from you guys. There's not much else you can do with it, but it's cool to see it out there, right? And then you'll have a whole list of these various screenshots that you have captured, in addition to the discussions that you're providing, explaining, you know, what I did here, what I did there, along with any other comments, suggestions, struggles, whatever. That's what this is meant to be, a collaborative space for you guys to work together. Okay, thanks for your patience observing this whole video. I know this was a lot to take in. It's all I got for you, though. I don't have any other reading materials, so you may want to watch this slowly and kind of go back and forth to complete what I'm looking for from this lab. Okay, I'll see you next time, guys. Thanks so much. Take care.